Hello guys, how are you today? So today I'll be explaining the course practice of Pure Mathematics section 2.1. It's chapter 2 section 1. Now regarding the periodic, we have 4 sections. What are the 4 sections? They are 2.1.1, 2.1.3, 2.2.1 and 2.2.2. These are subsections from the actual section, which is 2.1 and 2.2. Why? Because you will see on the SDP, in the course practice, 2 quizzes, one for 2.1 and one for 2.2. Now, 2.1, the full entire quiz is based on this and a little bit of 2.1.2, but 2.1.2 is really easy, so it doesn't really make a big difference. However, regarding the 2.2 quiz, it has from 2.2.1, 2.2.2, and it continues off. I don't know till where it finishes, but we have until a certain section, and there is the rest that we don't have for this periodic that is in the quiz. This is why in this quiz I'll be explaining it fully. In the other quiz I'll be like trying to find which questions are the ones that are from 2.2.1 and 2.2.2, and I will be explaining them as well. That I'm gonna do what the course revision questions. This is chapter 1, we don't have it, which is what we'll be doing chapter 2, all of section 1 and from questions 6 till 10 of section 2. So this is just a plan for the periodic because the quiz is like way too congested for 2.2, and there's like some material that is not for, like, we took it but it's not gonna come in this periodic. Okay, so anyways, with all that being said, let us start with the first question. Written in terms of factors, n plus 2, 3 is equal to n times n plus a times n plus 2 over b, where a and b is etc. They want us what? To find the values of a and b. طيب, what is this notation called? This notation is called what? A combination. Right? And if you remember from what we took in class, what is the rule for combination? If you have combination of nr, you will get a value of what? You will get a value of n factorial. If you don't remember what factorial is, it's very simply what? It's very simply, let's say for example, we have 2 factorial. It's 2 times 1 because you multiply 2 and then the number after it until you reach 1. Or if you have 100 factorial, it's going to be 100 times 99 times 98 times etc. all the way until you reach 1. This is the definition of factorial, right? Over what? Over n minus r factorial multiplied by r factorial. So this is the rule of the combination, okay? With that being said, let us apply it to the combination we have over here. So we have n plus 2, 3 combination. So what's it gonna be? It's gonna be n plus 2 factorial over n plus 2 minus 3 factorial times 3 factorial. Now, I'm gonna erase the general equation, and now we will need to what? We will need to solve it a bit more. So it becomes n plus 2 factorial over n minus 1 factorial times 3 factorial. Now, because we are dealing with n plus 2, the only way that we'll be able to reach 1 in this sense, because if you remember, if you're doing 10 factorial, it's 10 times 9 times whatever, all the way until you reach 1, right? So n plus 2, we don't know what is n. So in order for us to reach 1, it's gonna take us how much? It's gonna take us a very long time. So whenever you have a variable in the exclamation, it's gonna take you in the factorial, it's gonna take you a very long time to reach 1. Why is that? Because we don't know what is the value of n, or the variable. Now, what are we gonna do in this case? In this case, we're just gonna subtract 1 each time, right? What do I mean by this? I mean very simply, you started with n plus 2. What comes after n plus 2? N plus 1, right? We're subtracting 1, so n plus 2 minus 1. Then what comes after n plus 1? N plus 1 minus 1, n. And then what comes after n? N minus 1. Now, let's put a factorial here and let's write the denominator. What do you notice? What do you have in both the numerator and the denominator? You have n minus 1 factorial in common, so you can very simply, excuse me for this, cancel these out, right? So you can cancel out n minus 1 factorial and n minus 1 factorial in the numerator and denominator. Now, what will we have as the final result? We will have n plus 2 times n plus 1 times n over what? Over 3 factorial. Of course, you can expand it more. N plus 2 times n plus 1 times n. What is 3 factorial? 3 factorial is very simply 3 times 2 times 1. So it's what it is over 6. So in this case, what is the value of a and b? The value of a in this case is 1. And the value of b in this case is 6. Okay, so very simply it is 1 and 6. Let's move on to question number 2. What does it say in question number 2? Written in terms of factors n plus 1 combination 3. Let us do n plus 1 combination 3. What is it gonna be? It's gonna be n plus 1 factorial over n plus 1 minus 3 factorial times what? Times 3 factorial. Now, just simplify it more. So this is going to be minus 2 factorial, right? Because plus 1 minus 3 is minus 2. So now we have n plus 1 factorial over n minus 2 factorial times 3 factorial. Now, what are we going to do? We are going to expand this. So you'll remove the factorial and then you will subtract 1 every time. So n plus 1 times n times n minus 1 times n minus 2, stop. Same values, we put the factorial. And now we cancel n minus 2 factorial, n minus 2 factorial. And the final answer is what is n plus 1 times n minus 1 over 3 factorial, which is what? Which is 6. So the value of a in this case is 1, and the value of b in this case is 6. So 1 and 6. Let's move on to part b. What did they say? It's n plus 3 combination n minus 1. So n plus 3, n minus 1. We'll need to apply the rule. It's going to be n plus 3 factorial over n plus 3 minus n minus 1 factorial multiplied by what? Multiplied by n minus 1 factorial. Now, before you do any of the factorial, before you expand the factorials, you will need to solve these first, okay? So let's take it out for a bit. N plus 3 minus n minus 1. That is n plus 3 minus n plus 1. Minus n and n will cancel, and you will get 4. So very simply, we can replace all of this by what? By 4 factorial. Perfect, right? Let me just erase this. Now, let us expand n plus 3 factorial. Okay, let us expand it. It's going to be n plus 3 times n plus 2 times n plus 1 times n times what? Times n minus 1. Stop, because it's the same value here, and here we put the factorial. Now, because it's the same value up and down, n minus 1 factorial, up and down, we can cancel them. And we'll be left with what? We'll be left with n plus 3 times n plus 2 times n plus 1 times n over what? Over 4 factorial. You can put it on the calculator. So 4 factorial is what it is? 24. So very simply, the value of b in this case is 24, and the value of a in this case is 2. So 2 and 24. Let's move on to question number 3. What whole number is equal to 12 combination 3? Now, of course, if you want to save time, you can do it on the calculator. How do you do it on the calculator? You will do shift division. Okay, when you do shift division, you will get like a thick C, right? Whatever this is. Let's say this is the thick C. Okay, you will put the number on top before it and the number on the bottom after it. So if you do 12 combination 3, you will get an answer of what? Of 220. Now, of course, if you want to double check your answers, you can apply the combination rule. So it's going to be 12, not over, my bad. It's going to be 12 combination 3, which is what? Which is 12 factorial over 12 minus 3 factorial times what? Times 3 factorial. So put it on the calculator. Please do not forget the brackets. Very important to put the brackets. Okay, times 3 factorial, and you will also get an answer of what? Of 220. So as you can see, 220 here, 220 there, same answer. That means the answer is what? 220. Let's move on to question number 4. Okay, this is nice. What whole number is equal to 18 factorial over 4 factorial times 15 factorial? So let's write it. 18 factorial over 4 factorial times 15 factorial. Now, which is closer to 18? Is 4 closer to 18 or is 15 closer to 18? Definitely 15 is closer to 18. So what are we going to do in this case? In this case, we are going to what? We are going to expand 18 factorial until we reach the value of what? Of 15 factorial. So let's do it. It's going to be 18 times 17 times 16 times 15, same value, and then you put the factorial. Now you can cancel up and down, and you will be left with 18 times 17 times 16 over 4 factorial. You can put it on the calculator. 18 times 17 times 16 over 4 factorial, and you are supposed to get an answer of what? You are supposed to get an answer of 204. Let's move on to the next question, which is question number 5. Very important question. A simplified expression for this minus this is. Now, whenever you see two fractions, right, with different denominators and a minus in the middle, what are we supposed to do? We are supposed to find the least common denominator. So let us find, first of all, the least common denominator. Let's take the denominators aside. We have 3n minus 1 exclamation, or factorial. It's preferable to say factorial. Please do not say exclamation. Okay? And n plus 1 exclamation, or factorial. My bad. I keep on saying exclamation. That's very long. Okay? Now, let us look over here and over here. What do we have, right, in this value over here that we do not have in this value over here? First of all, there's a 3, right? There's a 3 times n minus 1 factorial, but there's no 3 here. So you will need to bring a 3 over here. Now, the next part is very important. You have n minus 1 factorial and n plus 1 factorial. Which one is bigger? For sure, n plus 1 factorial is bigger. So we will need to expand it until we reach n minus 1 factorial. So it's n plus 1 times n minus 1 factorial. Now, as you can see, there's n minus 1 factorial over here and n minus 1 factorial over here. But what is the extra thing that this has that this one does not have? It's very simply the n plus 1 times n. So the least common denominator is supposed to be what? It's supposed to be 3 times n plus 1 times n minus 1 factorial, excuse me. And for this one, because we already have this, we can write it as n plus 1 factorial, and we can multiply by which value? We can multiply by 3, right? So for this one, we multiplied it by n plus 1 and n. Why? Because we expanded this and we saw, okay, it has n plus 1 and n extra, so we will multiply it over here. And for this one, what is the thing we need to multiply it by? We need to multiply it by 3. Now, there's a rule, we've taken it over the years of being in school, and it is that whatever you do to the denominator, you have to do to the numerator. So you multiply here by n plus 1 times n. So here you will need to multiply by n plus 1 times n. And here you multiplied by 3, up you will need to multiply by 3. So let us expand it. It's going to be what? It's going to be n plus 1 times n over, let's start like this, over 3 times, let us say this is all what? N plus 1 factorial. So 3 times n plus 1 factorial minus, okay, do not forget the minus, 2 times 3, which is 6 over 3 times n plus 1 factorial. As you can see, they both have what? They both have the same denominators. Now that they both have the same denominators, you can what? You can combine them, and it's gonna be what? It's gonna be n plus 1 times n minus 6 over what? Over 3 times n plus 1 factorial. Now let me just erase these so we have more space. Okay, now after this, what are we gonna do? We are gonna expand. So what will it be? It will be n squared plus n minus 6 over 3 times n plus 1 factorial. So this is the final answer. This is the final form. So n squared plus n minus 6 over what? Over 3 times n plus 1 factorial. Let us submit, and hopefully we do not have any mistakes. And perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.